हेलो हेलो स्टूडेंट्स। आई होप आप सभी अच्छे होंगे और अपनी स्टडीज़ को भी अच्छे से कर रहे होंगे। हेलो स्टूडेंट्स, कैसे हैं आप सब? आई होप आप सभी अच्छे होंगे और अपनी स्टडीज़ को भी अच्छे से कर रहे होंगे। तो आज का जो हमारा टॉपिक होने वाला है वो स्टैट्स होने वाला है, स्टैटिस्टिक्स। और आज के इस स्टैटिस्टिक्स टॉपिक में जो हम थ्योरी देखेंगे वो मेनली उसमें हम रिजल्ट बेस्ड थ्योरी देखेंगे। ओके, मेनली रिजल्ट देखेंगे और प्रूफ इतने कवर नहीं करेंगे। ओके, जहाँ भी पॉसिबल होगा हम आपको प्रूफ देंगे और फिर इफ टाइम परमिट्स तो हम कुछ क्वेश्चंस भी करेंगे। तो चलिए आगे बढ़ते हैं। तो आज का जो हमारा टॉपिक होने वाला है उसमें हम क्या क्या कवर करने वाले हैं? मेजर ऑफ सेंट्रल टेंडेंसी, अर्थमेटिक मीन, ज्योमेट्रिक मीन, हार्मोनिक मीन, मीडियन, मॉड, रेंज, मीन डेविएशन, स्टैंडर्ड डेविएशन एंड वेरिएंस। तो ये सब हम आज के इस थ्योरी सेशन में कवर करने वाले हैं। There is a small disclaimer. The images used in our slide deck are just for educational purposes only. We respect the intellectual property rights of the original creator and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@itk.ac.in and we shall remove the images. Thank you. So the first thing, so what do we mean by measures of central tendency? A value which describes the characteristics of entire data is called an average or a central value. Generally, an average lies in the central part of the data and therefore such values are called measure of central tendency. Now, mean, the sum of all observations divided by the number of observations is called mean or denoted by x bar. The most stable measure of central tendency is mean. If you have x1 till xn n observations, then the mean is given by sum of all observations divided by number of observations. In summation form, you can write it as like summation xi divided by n. In other form, if you have assumed mean a, assumed mean a plus summation of di, where di is what? As you can see, the deviation from the assumed mean, xi minus a. Xi represents your observation. So xi minus a will be your di. So summation of all di divided by number of observation adding to assumed mean. This will give you your mean. Now if you have n observation with n frequencies f1, f2 till fn, then your x bar or mean will be fi f1 x1 plus f2 x2 till fn xn divided by f1 plus f2 till fn. In other form, summation of fi xi divided by summation of frequencies, or in terms of assumed mean, if your a is assumed mean plus summation of fi di divided by capital N, where di is your deviation, xi minus a from your assumed mean, and capital N will be the sum of all frequencies. If corresponding weights are given W1 till Wn to the corresponding observations, then the weighted mean can be evaluated by using this formula. X W bar means weighted mean is equals to sum of Xi Wi divided by sum of all weights. Now mean. So if you have x1 bar till xk bar, means of k different sets having n1 n2 till nk number of observations n1 till nk respectively. So x1 set having number of observation n1, x2 set having number of observation n2, and their respective mean is x1 bar, x2 bar, and so on. If you have to evaluate combined mean, then you have to use this formula. This x1 bar, x1k bar represents your combined mean from one set to kth set. Combined mean of k sets 1 to k. So you will have n1 product with x1 bar plus n2 product with x2 bar till nk product with xk bar divided by n1 plus n2 till nk. Okay. Here x1 bar represent your mean of first set. N1 represents your number of observation in first set. X2 bar represent mean of second set. N2 represent number of observation in second set, and so on. There is a note. The sum of the deviations of individual values from arithmetic mean is always 0. Mathematically, summation of xi minus x bar. So this is your deviation from arithmetic mean, which is x bar. So xi minus x bar, the sum of all such deviations would be 0. How? Let's just see a proof. So summation xi minus x bar can be written as in this form. If you expand this, x1 minus x bar plus x2 minus x bar till xn minus x bar, which is equals to x1 plus x2 till xn. We just grouped xi's together and x bars together. You will have this term minus n times x bar. Now this is your what? Sum of all observations, and in terms of mean, arithmetic mean, this can be rewritten as n times x bar, and we already have minus n times x bar, so this will be 0. So that's why you have this summation of xi minus x bar is equals to 0. Okay, so from where we have written this, very simple, by the definition of average, by the definition of mean, the sum of all observation divided by number of observation is equals to x bar. So we just took this n to the right hand side, and we got the sum of all observation is equals to n times x bar. Now second point, the sum of squares of deviations in of the individual values is least when taken from arithmetic mean. So xi minus x bar whole square and then summation will be the least. Now geometric mean. If you have n observation x1 to xn, then the nth root of the product of all observation, we define it as geometric mean. Mathematically, if you have x1 to n non-zero positive observation, then geometric mean by definition will be the nth root of the product of all observations. Now if you have frequencies, corresponding frequencies to the observation, like f1 to observation 1, f2 to observation 2, until fn to observation n, then the geometric mean will be, by definition, x1 raised to the power f1, x2 raised to the power f2, till xn raised to the power fn, and then whole power raised to the 1 by capital N, where your capital N will be the sum of all frequencies. Now harmonic mean. The harmonic mean of any set of non-zero observations is the reciprocal of arithmetic mean of reciprocals of the observations. Meaning, if you have n observations, then first of all, reciprocal each of the observation, you will have 1 by x1, 1 by x2, and so on. Then find the arithmetic mean of that and then reciprocal it again. So by definition, it will be, the final result will be like n divided by 1 by x1 plus 1 by x2 till 1 by xn. And this can be rewritten as 1 by n summation of 1 by xi. And this whole can be rewritten as 1 by n summation 1 by xi raised to the power minus 1. If you have corresponding frequencies f1 to fn, then harmonic mean can be rewritten as, by using the same analogy, we will have 1 by capital N summation fi divided by xi whole raised to the power minus 1. Now relation between am, gm, hm is gm whole square is equal to am product with hm. Now median. If the observation are arranged ascending or in descending order, so if you have to find out the median, then you first have to arrange your data set in either ascending form or in descending form. Then the value of the middle observation is defined as a median. In that you will have what? Suppose if you have n observations, and if you arrange them in ascending or descending order, then you will have, if number of observations is odd, then the median will be just represented by this form, which is n plus 1 divided by 2, and this position n plus 1 by 2th position observation will be your median. What if your n is even, the number of observations are even, then the median will be represented by just nothing but the average of, or mean of, the n by 2th position plus n by 2 plus 1th position. Simple. Now if in a continuous distribution, if you have class distribution, continuous distribution, the total frequency is capital N, then the class whose cumulative frequency is either equal to n by 2 or just greater, okay, just greater than n by 2 is called a median class. And in that case, median will be L plus n by 2 minus c divided by f product with h, where your L will be lower limit of median class, f will be the frequency of the median class, h will be the size of the median class, c will be the cumulative frequency of preceding median class. Now mod. So mod by definition is just nothing but the observation which has maximum frequency. If you have n observations and corresponding frequencies are these one f1 till fn, then the observation of maximum frequency will be your what? Modal value. In a continuous distribution, the interval which has maximum frequency called modal class, and in that case mod will be L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 product with H, where L will be your lower limit of modal class, F1 will be the frequency of the modal class, F0 will be the frequency of class preceding the modal class, F2 will be the frequency of class succeeding the modal class, and H will be the class size. Now the relation between mean, median, mod is just nothing but mod is equals to 3 median minus 2 mean. It is not necessary that a distribution has unique mod. You can have two or more than one mod. Now measure of dispersion. A measure of dispersion is designed to state the extent to which the individual observation vary from their average. So this just is designed to tell about the individual observation, how much varies from their average. The commonly used measure of dispersion are range, mean deviation, standard deviation, variance. Now range, the difference between maximum and minimum observation, we define it as range. So L minus S, where L is your maximum observation and S is your minimum observation. Now coefficient of range is defined like L minus S divided by L plus S. Now mean deviation. Mean deviation, the mean of absolute deviations of values of the variable from a measure of their average is called mean deviation. So mathematically, if you have n observations, then the mean deviation will be the absolute. So this is your the deviation and this is absolute value of your deviation. So xi minus z, where z can be mean, median, mod, and this mean, the mean of the deviation, absolute values of the deviation will be your mean deviation. If you have corresponding frequencies, then mean deviation formula will be summation of fi product with absolute value of xi minus z divided by capital N, where z is the same mean or median or mod, and capital N is sum of all observations, and fi is your frequency. Now coefficient of mean deviation is defined like mean deviation divided by corresponding average. Now mean deviation is least when deviation are taken from median. So if z is equals to median, if you use z as your median, then your mean deviation will be the least. Now standard deviation, the square root of arithmetic mean of the squares of deviation taken from their arithmetic mean is called standard deviation and is denoted by sigma. Mathematically, if you have n observations, then summation xi minus x bar whole square. So this deviation from your mean, so deviation from their arithmetic mean, xi minus x bar, it's his square. So as you can see, it's a square, and then taking arithmetic mean again. So arithmetic mean of the squares of the deviations you will have, and then the square root By definition, your mathematical expression would be like this: root of summation of xi minus x bar whole square divided by n. In other words, this can be rewritten as like this: 1 root of 1 by n summation xi square minus 1 by n summation xi then whole square, as you can see. So what's the difference between these two formulas? So in this formula, you must know about the arithmetic mean, but in this formula you do not need any information about the arithmetic mean. You can by just using your observations in this formula, you can easily evaluate your standard deviation, while you can only use this formula when you have knowledge about the arithmetic mean. Okay, now let's see a proof that both expression are equal to each other. So sigma square, so we are starting from here, left hand side. Sigma square is equals to summation of xi minus x bar whole square divided by n. Now observe that this, the numerator term summation xi minus x bar whole square, is can be rewritten as summation of xi square minus 2xi x bar plus x bar square, and this further can be rewritten as summation of xi square minus 2x bar product with summation of xi plus n times x bar square. We also know by the definition that arithmetic mean is defined as x bar is equals to 1 by n summation of all observation. In numerator, summation of all observation divided by number of observations. From here you can easily see, if you square both sides, you will have n product with x bar square can be rewritten as summation of xi product with 1 by n summation of xi. So this gives you that 2x bar summation xi can be rewritten as 2 times of 1 by n summation xi summation xi. So you can easily replace things. You will have this, that summation of xi minus x bar whole square can be rewritten as now in terms summation xi square minus 2 times of 1 by n summation xi product with summation xi plus n product with 1 by n product with summation xi whole square. So you can easily see this term and this term can be merged together, and you will have what? Now reduced expression will be summation of xi square minus 1 by n summation xi whole square. So this completes your proof that a sigma square is equals to 1 by n product with summation of xi square minus 1 by n summation xi whole square. Now, what if you are given with their corresponding frequencies? Then your standard deviation will be like root of summation fi xi minus x bar whole square divided by capital N, where capital N is your sum of all frequencies. Now, in other terms, you can rewrite the same thing in this form, like root of 1 by capital N summation fi xi square minus 1 by n summation fi xi whole square. Okay, now let's see a proof that both the expression are equal to each other. So starting with left hand side, sigma is equals to root of summation fi product with xi minus x bar square divided by capital N. Squaring both sides, you will have sigma square is equals to summation fi product with xi minus x bar square divided by capital N. Now observe that the numerator term fi xi minus x bar square, a summation can be rewritten as summation of fi product with xi square minus 2xi x bar plus x bar square, and further this can be rewritten as summation of fi xi square minus 2x bar product with summation of fi xi plus summation of fi x bar square. Now you know that x bar square summation fi is equals to what? Capital N x bar square, where you all know that how we define capital N. It is just nothing but sum of all frequencies. Now 2 times of x bar summation fi xi can be equal to 2 times of n capital N x bar square. This now can be rewritten as summation of fi xi minus x bar whole square is equals to now summation of fi xi square minus 2 capital N x bar square plus capital N x bar square. This right hand side reduced to summation fi xi square minus capital N x bar square. This gives you sigma square is equals to 1 by capital N product with summation fi xi square minus capital N x bar square. So sigma square is equals to 1 by n sigma fi xi square minus x bar square. And we know that x bar square is just nothing but summation fi xi divided by capital N whole square. And by replacing, this completes the proof. Now variance. The square of standard deviation is just variance and denoted by sigma square. The coefficient of variation is just nothing but sigma divided by x bar product with 100%. Two different series having n1 and 2 observations whose corresponding means and variances are x1 bar, x2 bar and sigma 1 square, sigma 2 square respectively, then the combined variance is defined like this. Combined variance is sigma square is equals to n1 sigma 1 square plus n2 sigma 2 square plus n1 d1 square plus n2 d2 square divided by n1 plus n2, where your d1 d2 are just x1 bar minus this combined mean uh, x12 bar, and d2 is x2 bar minus x12 bar. And the combined mean, from the combined mean you can easily evaluate x12 bar as n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Now variance, if x1 x bar me mo and sigma represent the mean, median, mode and standard deviation respectively of n observations, then mean of ax1 plus b, ax2 plus b till axn plus b will be ax bar plus b. Let's see a proof. So mean is just nothing for this data set is the sum of all observation divided by number of observations. So you will have sum of all observation divided by number of observation. This gives you that you can easily group things together and take a common. You will have a product with x1 to summation of xn divided by n plus n times of b divided by n. After reduction, you will have a product with x bar plus b. So the new mean will be a x bar plus b. Now median, in case of median, so if ax1 b plus b, ax2 plus b till axn plus b, then its median will be ame plus b. Let's see a proof. So original data set n observation with median ME. If n is odd, then simple. The old median will be what? The observation at n plus 1 by 2th position. Then the median for new data set will be n plus 1 by 2th term of the new data set. So, the new, according to the new data set, the n plus 1 by 2th term will be ax n plus 1 by 2th term plus b. So this is just nothing but the old median. So AME plus B. Now for even case, the old median would be xn by 2th term plus xn by 2 plus 1th term average. So divided by 2. So median for new data set will be the average of, or the mean of, n by 2th term and n by 2 plus 1th term. So new median will be a x n by 2 plus b plus a x n by 2 plus 1 plus b divided by 2. Grouping together, you will have a product with x n by 2 plus x n by 2 plus 1 divided by 2 plus b. And as you can see from here, this is just nothing but ME. So new median will be AME plus B. Now mod. Mod of this data set AX1 plus B, AX2 plus B till AXN plus B will be AMO plus B. Let's assume MO be a mod of this observation, the old data set. Then this implies that M not appears more than any other observation in the data set. Okay, in this data set. Now standard deviation of ax1 plus b, ax2 plus b till axn plus b is absolute of a product with old standard deviation. Let's see a proof. So an observation having sigma as its standard deviation, and this is equals to root of 1 by n summation xi minus x bar square. Now new deviation will be for a new data set which is ax1 plus b till axn plus b. So the new standard deviation can be evaluated as root of 1 by n summation of, as you can see, the deviation square deviation will be each observation axi plus b minus the mean for this data set, which is which we already have evaluated, which is ax bar plus b, then whole square. Then you will have what, that b will cancel. You will have axi minus ax bar square. Taking a common, you will have root of a square by n summation xi minus x bar square. A square or a can be taken outside, as a already have a square and we are taking root, then it will be mod a product with root of 1 by n summation xi x bar square, and this is your what? This is your old standard deviation for your old data set or the original data set. So new standard deviation will be absolute value of a product with old standard deviation. So this is the end from the theory side. So just wait for some moment. We will be back with some questions. So thank you for waiting. Let's just explore some questions related to the theory. So statistics practice questions. So what we will do, question 1 to 6, if time permits, we will do all the questions. Now there's a small disclaimer. The images used in our slide deck are just for educational purposes only. We respect the intellectual property rights of the original creator and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathi@iitk.ac.in and we shall remove the images. Thank you. Now the question. So the mean of a data set consisting 20 observation is 40. If one observation 53 was wrongly recorded as 33, then the corrected mean will be what? 41, 49, 40.5 or 42.5. Very simple question. Number of observations you are given, the mean already given, and it is already given to you that the one observation was wrongly recorded as 33. Okay, so then what will be the correct mean? So you will have 30 seconds to solve or to try this problem. After 30 seconds, we will jump to the solution and its explanation. So your time starts now. So students A option मतलब 41 आंसर्स बता रहे हैं. ओके, नाइस. तो काफी स्टूडेंट्स ऑप्शन ए को करेक्ट आंसर बता रहे हैं. सो जैसा कि टाइम ओवर हो चुका है, बट स्टिल यू कैन गिव योर options. Okay, so now we are now moving to its solution. So let's see what will be its correct option. So you already know the question. Question is saying that if the data set consisting of 20 observation and the mean is 40, if one observation is 53 which was wrongly recorded as 33, then the corrected mean will be given by option A. So well done, very good. All of those who given option A as their answer. So let's see that how we are getting option A. So first of all, formula and key points used in this solution. Mean, the definition of mean, which is sum of all observation divided by number of observations. Now let's see solution. So summation x incorrect divided by 20. So by definition you have this thing. So mean is given to you as 40 of the wrongly data. Okay, so we interpret this information to this expression or this equation. Now the summation of x incorrect will be what? 800. If you subtract 33 which was wrongly recorded and add 53, then the left hand side will become x correct, summation of x correct, and it will be 820, and divide by 20 as because the number of observation are just 20, so by definition sum of all observations, so sum of all correct observation divided by number of observation which is 20 is equals to 820 by 20. So this will be just nothing but your 41, and this will be your the correct mean. That's why option A is your correct option. Okay, I hope the explanation is clear to you. Let's move on to the next question. Now, question 2. You are given with, if the variance of these 10 observation 1 to 10, the variance is 99 by 12, then the standard deviation of 3, 6, 9 till 30 will be what? 297 by 4, 3 by 2 root 33, 3 root 99 by 2, root of 99 by 12. So what will be the standard deviation of this data set, this new data set? Very simple. If you have paid attention to the theory class, then this will be a very easy question for you. So you will have 30 seconds to try this problem. Okay, after 30 seconds, we will be seeing its solution. So your time starts now. So students option D को करेक्ट बता रहे हैं. ओके, मेजॉरिटी स्टूडेंट्स ने अभी ऑप्शन डी को ही चूज किया है एज देयर करेक्ट ऑप्शन. एज टाइम्स ओवर. तो चलिए देखते हैं कि इसका करेक्ट ऑप्शन क्या होगा और क्यों. तो जैसा कि क्वेश्चन में वेरिएंस हमें दिया हुआ है इस डेटा सेट का और स्टैंडर्ड डेविएशन पूछा जा रहा है इस डेटा सेट के लिए, जो कि इसका की करेक्ट ऑप्शन रहेगा ऑप्शन बी, जो कि है 3/2 रूट 33. आइए देखते हैं कैसे. तो सबसे पहले जानेंगे कि हमने क्या फॉर्मूला यूज करेंगे. स्टैंडर्ड डेविएशन होता है बाय डेफिनेशन रूट ऑफ समेशन एक्स आई एक्स बार स्क्वायर डिवाइडेड बाय एन. ओके. वेरिएंस क्या होता है? सिंपल, इसका स्क्वायर जो कि होता है सिग्मा स्क्वायर इक्वल्स टू समेशन एक्स आई माइनस एक्स बार होल स्क्वायर डिवाइडेड बाय एन. और एक इंटरेस्टिंग थ्योरी में रिजल्ट था, जो कि क्या था कि अगर आपके पास एन ऑब्जर्वेशंस हैं और उसका एक स्टैंडर्ड डेविएशन है सिग्मा, तो हमारे पास इस जो कुछ इस तरीके का डेटा सेट जब आप जनरेट करेंगे पुराने डेटा सेट से, वो किस तरीके से, हर एक ऑब्जर्वेशन में हमने एक के साथ प्रोडक्ट किया और प्लस बी हमने उसमें ऐड किया, देख सकते हैं आप. तो ये जो अब नया डेटा सेट जनरेट हुआ है, इसका जो स्टैंडर्ड डेविएशन होगा वो क्या होगा? मॉड ऑफ ए प्रोडक्ट विद ओल्ड स्टैंडर्ड डेविएशन. सिंपल. आइए सॉल्यूशन को देखते हैं. क्योंकि हमें सिग्मा स्क्वायर वेरिएंस दिया हुआ है, तो सिग्मा स्क्वायर दिया हुआ है 99/12, जिसे हम सिंप्लीफाई कर लेंगे, जो कि क्या आ जाएगा 33/4. इसका मतलब सिग्मा जो कि है स्टैंडर्ड डेविएशन, वो क्या होगा? रूट 33/2. और न्यू डेटा सेट के लिए जो कि है 369 टिल 30, जो इस डेटा सेट के लिए यहाँ पर ए क्या है? बी तो है नहीं, बी कुछ भी ऐड नहीं हो रहा, लेकिन ए क्या है? 3 है. अगर आप ओल्ड डेटा सेट में बी को 0 रख दें और ए को 3 रख दें, तो इसके अकॉर्डिंग हमारा जो स्टैंडर्ड डेविएशन है वो क्या आएगा? मॉड 3 प्रोडक्ट विद ओल्ड स्टैंडर्ड डेविएशन. तो ओल्ड स्टैंडर्ड डेविएशन ये है, 3 हमारा ए है, मॉड 3 3 रहेगा, तो 3 टाइम्स सिग्मा. तो हमारा न्यू ये जो 369 टिल 30 जो स्टैंडर्ड डेविएशन आएगा इस डेटा सेट के लिए, वो आएगा 3 प्रोडक्ट विद रूट 33 डिवाइडेड बाय 2, जो कि हमें ऑप्शन बी में दिया हुआ था. तो इसी के साथ साथ हम अपने इस लेक्चर को यहीं पर एंड करेंगे. ओके, आई होप you enjoyed this theory and practice question session. So once again, thank you.